Hello everybody, welcome back. Today we're looking at example 1 from section 7.5. It says the entry to the main exhibit hall in an art gallery has a parabolic arch. The arch can be modeled by the following function. H of W, so height as a function of its width, that's what that means, is equal to negative 0.625 W squared plus 5W. Okay? Where the height's given by the function hw, and the width, w, are measured in feet. Several sculptures are going to be delivered to the exhibit hall in crates. Each crate is a square-based triangular prism that is 7.5 feet high, including the wheels. The crate must be handled as shown to avoid damaging the fragile contents. Determine the distance between 2 points of the arch that are 7.5 feet high. All right, so to do this with factoring, if I was doing this graphing, it would be a completely different way. So first thing you want to do is set height equal to 7.5. Okay, so that's the first thing you need to do. So there's our equation in order to do that. Take our equation and we set the height equal to 7.5. Okay. The second step is we need to put it in the form. Put in the form of. We need to put it in the form of ax squared plus bx plus c. All right. So basically, we want to have, and again, the zero can be on either side of the equal sign. It can be on the left-hand side or right-hand side, and then everything to one side, just like we did in some of the practice earlier on. Okay. So we'll take the equation. We're going to subtract 7.5 from both sides. That's the easiest way to do this one by the looks of it. Subtract 7.5 from both sides. That will make that 0. Right? Okay. So we subtract the 7.5 from both sides, and this is what we get. Now, what you want to do is you want to make this coefficient in front of the w squared 1. Positive 1 is what you want to do. So I'm going to divide every single term by negative 0.625. So I'm going to divide all terms by negative 0.625. To make that coefficient in front of the w squared, that's just like x squared, by the way, right? That's when I set it up here. It's just we're using w instead of x. So we take our equation. All terms by negative negative 0.625. Divide this by negative 0.625. So you notice divide everything here. Okay. Then we're going to clean our equation up. When I say clean it up, I mean simplify, right? So 0 divided by negative 0.625 is just 0. These here divide out, and obviously they equal 1. That's why we did it. Right? That's the whole idea. And we take 5 and divide it by negative 6.025, we end up with minus 8w. We divide negative 7.5 by negative 0.625, and we end up with positive 12, which becomes this beautiful quadratic equation. Now we need two numbers multiplied together to give me 12, add together to give me negative 8, and we all know that they are negative 2 and negative 6. So w minus 2 and w minus 6. So that means that we set both equal to 0. So we separate and set both equal to 0. Okay. And W is equal to 2. And W is equal to 6. Add 2 to both sides. Add 6 to both sides, and we get W equals 2 and W equals 6. So the answer to the question, therefore, the width at a height of 7.5 feet is, take 6, subtract the 2, that equals 4 feet in the difference. Okay? 4 feet in a difference. So, if I was doing this graphically, which I do, I find it like, algebraically, it's good to do, but this can be done in seconds on a graphing technology. I'm going to show you how to do that on the graphing calculator as well. Now, we don't do a whole section on this, but I am going to show you quickly how to do that. So there's a couple ways to do it. The first way would be to plug in the equation when we set it equal to 0. So we add it to 7.5, and we get y, and we just put y equals negative 0.625x. I just use x and y instead of the h and w, just to represent that. So x squares, okay, plus 5w, and then we subtracted the 7.5 from both sides. Okay, oh, not w, we use x, sorry. And there we have that. We have the graph like that, and that's where the 2 and 6 comes from. Okay, we do it that way, and that means that's the width, right? So the door has to be 6.2 or 4 feet wide in order to maintain that height. Okay. Another way to approach this question is if we set this equal to exactly what we had at the beginning, so we just set it equal like that. Again, you can get the two equations there. It just gives you the same width, but setting it equal to 0 to show the factor form, minus the 7.5. There's your quadratic. Now it opens up really high. There you are. Oh, there we go. Sorry. Y equals. So that can be done as well. Okay. There you go. Another way to show this is to do left-hand, right-hand side. So set these two as equations and do the 7.5. And I'll scroll up there a bit. And I find this really helps, actually. It gives you an idea of the width there. A better visual, I think, maybe is the right way. But we'll talk about that when we get to there. But either way, it's the distance between the two x values. 6 subtract 4 is, sorry, 6 subtract 2 is 4. Okay. Next, what we're going to do is we're looking at an equation. It's called difference of squares. So you may remember that when we had perfect squares and there was no bx term, you may recall. Okay. No b term. So what we do is we'll take our equation, which is the difference of squares. It may not look like it right now, but it is actually going to be the difference of squares. We're going to factor out a 3. So when I factor out a 3, I'm left with 3 bracket 25p squared, which means I also have to factor out a 3 from the 192, which leaves me with 64. Okay. So once I do that, now I can factor these. You'll notice 25p squared is a perfect square, 64 is a perfect square. There's a difference between them, so now I'm going to factor that. These were easy to identify once you got the GCF out, I found. Okay. So then I end up with 5p Take the square root of 25p squared, you're left with 5p. Take the square root of 64, you're left with 8. And then you had to do the same terms, only with a plus, right? And you end up with, now the 3 is not going to make a difference here. We can divide the 3 out, it's gone. So you're left with 5p minus 8 is equal to 0, and you're left with 5p plus 8 is equal to 0. Solve both these, so we're going to add the 8 to both sides on the first one. Okay, so by adding 8, that's removed from the left-hand side, add 8 to the right-hand side, and simultaneously we'll subtract 8 from both sides here. And that's minus 8, right? Just doing it at the same time. So now we're left with p is equal to 8 divided by 5, and you're left with p is equal to negative 8 divided by 5. Okay? And those are your two roots. Now to verify your solution, so when we verify a solution, I take these out to the right. So we verify a solution. It looks like this. Verify. So we take the original equation. Take the original equation. And I'm not going to do both. I'll set one of them. Okay. So anywhere say p, I'm going to put 8/5. And again, if it was negative 8/5, it would just square and give you the same, you'd be doing the same thing twice. Just do one. One sample calculation is more than okay. So you square the numerator and square the denominator. So 8 squared is 64, and 5 squared is 25. So you end up with 64 divided by 25. Minus 192. So I'll notice that 75 divides by 25. So that'll give you 3, right? So 75 divides by 25 gives you 3 here. In the front, 3 times 64, right? So I did 75 divided by 25. I recognize that was 3. And then we end up with 192. Subtract 192. And 0 is equal to 0, obviously. So this just shows algebraically you did it correctly. Okay? Show you a little trick on the graphic technology before we go to example 3 in the next video. To solve this, just plug this in with y equals on the graph. I'll do it on the graphing technology this time, graphic calculator. So what you want to do in Desmos, when it's equal to 0, just put it in y equals. So you see the function, y equals, and it was 75x squared. Now that was p, but you can just put in x. Minus 192. And you'll notice you get negative 1.6 and 1.6, which is actually 8/5 and negative 8/5, right? So that's all you're solving for there. All right, so that's it for this video. Next video, we'll continue with example 3. Thank you, everybody, for watching, and we'll talk again soon.